Hi, we're Group 1 G.E.A, Greenhouse Environmental Analyzer of blue to red light CO2 temperature and humidity.
Hi, my name is Raul Graterol and my major is computer engineering.
I'm Maya Sosa and my major is photonic science and engineering.
Hi, I'm Leiner Suarez and my major is electrical engineering.
I'm Weiner, photonic science and engineering.
So we chose this project to tackle the issue of there not being an all-in-one monitoring system to monitor greenhouse parameters. With the rise of the usage of greenhouse in the agricultural industry, it's important that one product can control all the parameters and measure them, and also have that included blue to red ratio, because recent research has shown that this blue to red ratio can impact photosynthesis and crop yields.
Our objective is to have all the sensors in a single plate, so it'll be easier and faster for a greenhouse to monitor.
The broader impact of this product is that it's going to bring to the industry not only a CO2, humidity, and temperature sensors, it's also going to bring blue to red light radio. That will be totally changed since it can help the plant in all the growing stages.
So this is G.E.A, this is our project. Her housing is made with PETG. The reason we chose to go with PETG is because it has high durability and high resistance to heat and moisture, which are two elements that are found in greenhouses. So if we remove the top, we can see our main PCB, and then Paul is going to tell you more about the sensors.
Okay, and these are our three different lenses. And so this is our white light sensor, this is our red light sensor, and this is our blue light sensor. Within these sensors, we have filters, and so we have a red light filter and we have a blue light filter in there to filter the light. And this is our CO2 temperature and humidity sensor. Okay, so talking about our filters, the reason that we're using our filters is because we received a major amount of feedback in Senior Design 1. During our final demo, we realized that the diffraction grading method was not going to work as light sources can move, and because of that, the diffraction pattern of the red and the blue would just shift across the sensors themselves. That was not going to be a good approach, and so we got some feedback to completely ditch that idea.
PCB, the highlighted component is the microcontroller ESP32. This is the battery holder and the main source of power of this, the battery. This little chip is the USB to UART to program the microcontroller. This is the I2C splitter that we need in order to communicate with all the sensors, since all of them has the same I2C address and we only want one I2C bus. The component that I highlighted now is the USB port and the switch that is in order to select the battery mode or the programming mode. Then we go to the back to the PCB. In the left side, we can see the red light sensor, then the blue light sensor, then the one connected with the cable is the light sensor, and in the middle of the PCB, we can see the CO2 and humidity sensor. We use a cable for the light sensor, for the general light sensor for troubleshooting featuring. And finally, here is our second PCB. So this PCB is more than an iteration of the first one, but instead of having the sensor, we have the LEDs that we're going to control through the app, so we can control the red and blue radio through the plant.
It's our app. Right now we are trying to log in there. When we sign in, we are sent directly to a homepage. In the homepage, we have different areas that we could go to. In the first one, we have a analyzer of blue to red light, and then we're gonna go further with more information in the video. We also have a temperature readings. We're gonna go over it in the future in the video. We have the LED controller with automatic mode and also manual mode, and then we also have the threshold adjustment.
In our makeshift greenhouse here, we have G.E.A, and then we have a leaf succulent. So say there was a farmer with a greenhouse full of leaf succulents. Leaf succulents take a ratio of 1 to 5 blue to red, and that's what helps them grow. So in our demonstration here, we can turn on red lights. And then in the same app, we can go to our lux reading meter, and then we can then see the white lux, the red lux, and the blue lux, and it also tells us the ratio. And if we go and put our LEDs into the automatic setting, then it can automatically adjust to that ratio. and we will do more demonstrations on how the automatic adjustment works later in the video.
Our app. Currently, we will be measuring how fast the app updates. When we press this refresh button, it'll read from the server what these sensors are getting, and we'll display them here. We're screen recording on this phone, so you can see. So we will press refresh now to see what the current values are. Right now, we are reading a white light value of 112, red light of 2, and blue of 2. And that's without the filters being calibrated yet. So if we shine the light on there, we can refresh again. Our specification was for 40 seconds, so we can do it now. And you can see that we got 6, 28, 22, and 47. Now you can turn the light off again, and we can press refresh. It'll take another second or so. And then we have 112, 2, and 22. You can shine on there again. And you can see it updates pretty quickly. So, yeah, I guess we keep doing that. Yep, and it should, yep, very quick. Less than 40 seconds, so probably less than 10, which is good.
To test the accuracy of our photodiode sensors first, we're going to put our project in various lighting conditions and show the readings from both the app and the independent lux meter, which you can see on the board right there. We have removed the lid of our project so that our sensors and the lux meter can be on even ground to get accurate readings. And since this testing has no moving parts, we will simply show the readings and tabulate our data. Here we can see our results from all 4 testing setups. Obviously, our engineering specification is over 10,000 lux, such as would be found in a greenhouse. However, due to the nature of where our showcase is going to be, we also did lower light levels. And as you can see, even in those lower light levels, we are within our 10%, and the higher in lux we go, the even better our percent error is. This is our setup for testing our red sensor. As you can see, our lux meter also has the filters on it, such as our sensors do. And we have the LED panel up top with our plant. And we're going to test our red sensors now, just how we tested our white sensors. Here are the results of the test runs we did for the red LEDs and blue LEDs. As you can see, for the red especially, our percent error was very good. It tended to stay very accurate. For our blue LEDs, we did not include all the LEDs off since the blue was at 0, and that did affect our output. However, we can see from the other ones that it is also within our engineering specification. Now that we finished our tests to ensure the accuracy of all of our sensors, both the white and the red and the blue, now we're going to move on to the testing of our LED panel. Okay, so in the app, I'm going to switch it from manual mode to automatic mode. And then I'm going to go to the analyzer blue to red light so we can see the actual ratio. Right now we are under leaf succulent, which is what this plant is right here. So we want a ratio of 1 to 5. And we can see here that it is changing automatically. Okay, so now our actual and desired ratio is 1 to 5. So we can see that it works.
Right now you can see that our lux values for the red and blue are 0 to 1. So we have 16 red, 0 blue. To fix that, we will go to the LED controller and turn off manual mode to toggle on the automatic mode, since we want a ratio of 1 to 5. It's still ring 16.0, so we will hit refresh. And because of that, now the blue LED should turn on. To accommodate for that, since we don't want E0 lux. So right now we are reading 3916, which tells us that we need more red on. And so because of that, an LED will turn on for the red. And now we're reading a ratio of 3950. We still need more red. And so it will update, know that. And now we have a ratio of 39 to 83. That's still not large enough, so we will turn on another LED. And now we are reading a ratio of, once again, 39 to 83. Now we're reading a ratio of 39 to 150, which is 13 to 50. Now we're reading 39 to 184. And it may stick there, yeah, 39 to 184. So that is it. That is good. All right, now that we've done the 1 to 5 automatic light adjustment, we will start with the 1 to 3. So I'll turn off manual mode and go to the analyzer and switch the wanted ratio to 1 to 3. And so right now we can see that we have a ratio of 34 to 75. And if we keep pressing it, we can see that now we have 17 to 46.